Now let us start with the session on SAP HANA installation and its post steps. So basically, in this session, we will be understanding what are the preparation requirements needed for installing a HANA database server and how do we install it after getting the preparations ready, and after installation what are the needed post steps so as to configure the SAP HANA for productive use. First, let us start with installation preparation. Basically, what do you mean by installation preparation? In layman language, for any installation or any implementation, we have to prepare the hardware and also get the necessary software package and then proceed with the installation. So, on similar lines, for implementing an SAP HANA appliance or a server, we require right planning for achieving the desired performance of the product. Unless we prepare the hardware and install the software package in the right way, we cannot achieve the desired performance of the product. So, what are these preparation steps so that we can proceed to install SAP HANA software? Step 1 is firstly we need to refer PAM. PAM is called as Product Availability Matrix, which is a part of Service Marketplace. So we need to refer PAM for SAP HANA installation so that we can choose a certified and supported hardware to proceed with the installation. And this is the URL where we can navigate and look in for the supported operating systems. So once we navigate to this URL, we have to search for the product SAP HANA Platform Edition 1.0, and from there that will list the supported operating systems. So we will get to know the supported operating system releases which can be used for installations. So that's the first step. Once we have decided which operating system has to be used for installing SAP HANA database server, next step is about designing or about sizing the hardware so that we can proceed with the installation. What do you mean by sizing? Sizing basically means sizing the server with the needed hardware like CPU, memory, and the storage disks. In SAP HANA, sizing is mainly based on the required main memory. From required main memory, we mean the amount of data, the productive data to be kept in main memory is measured so that we can design the main memory according to that. Main memory is nothing but RAM. So RAM sizing basically depends on the amount of productive data the system should carry. This can vary based on the scenario the system is going to be used. For BW it is different, for SAP Business Suite systems it is different, for NetWeaver it is different. So based on the scenario of implementation, the size of the main memory can vary. And main memory sizing is basically dependent on static data and dynamic data. Static data means static RAM size and dynamic data means dynamic RAM size. So by static we mean that the size of RAM, that is amount of main memory that is used for holding the table data. These are static in nature. No doubt the changes are done on these data, but they are the table structure data. Coming to dynamic data, which is the dynamic RAM size, this is the additional memory required for data loading and query execution. And this by design is measured as equal to static RAM size requirement. And by dynamic sizing, we reserve it for data loading and query execution. So this dynamic RAM size is mainly for design time usage. During design time, we will develop new objects to do data loading into them, and we do query execution. So for all these purposes, we need dynamic RAM size. And going further, so now we have understood what is main memory, how does the sizing of main memory take place. There are some of the recommended SAP notes provided by SAP for an administrator to refer so that right sizing of the server can be achieved. For example, note 1514966 explains about sizing of SAP HANA appliance. So if it is a standalone database, how the sizing should be is explained in this SAP note. And further on, SAP notes like 1944799 explains guidelines for SUSE operating system installation. So for SAP HANA installation point of view, how SUSE operating system, SUSE Linux operating system must be sized is explained in this. And the next note 2009879 explains guidelines for sizing Red Hat Enterprise Linux for SAP HANA installation. And SAP note 1736975 explains about sizing of BW product on HANA. For installing BW product on HANA, what sizing measures do you follow is explained in this. And next is 1872170, which will explain about sizing for business suite product installations on HANA. This is the first SAP note mentioned, which talks about sizing SAP in-memory database. So here they have mentioned some information about SAP in-memory appliance, where definitions and the advantages of SAP in-memory is written as a whole. Coming to solution part here, you see that the recommendation here given is to follow the quick sizer tool for sizing the hardware. Quick sizer is a part of service marketplace again, can be accessed using this URL. And coming below, this section explains about the sizing of SAP HANA in memory database as a whole. There is a sizing guideline provided in this SAP node. This attachment will give certain guidelines for sizing the hardware, which must be gone through. And how do we determine the data footprint of the data? For example, how do we determine the amount of data that is to be stored in memory, the amount of disk space required? So all that is explained in this. And if, for example, if we are migrating an existing SAP solution running on any of the traditional databases to SAP HANA, there are certain scripts included in this SAP node. For example, this script for DB6 and this one for Oracle. So these scripts can be executed, and after execution we will have results with the table size.txt with the result where it shows table names and their respective sizes. So that can be referred for proper sizing of the hardware to decide on how much memory is essential for running the solution which is going to be migrated to SAP HANA. So likewise, for different databases, the recommendations are mentioned here. Uh, Necessary scripts are included in this, and necessary SQL commands are provided in this so that we can fetch the information and then plan accordingly for sizing the target hardware. And next is about CPU sizing. We know that from sizing we mean to size RAM, CPU and the hard disk. So coming to CPU now, yes, for CPU again the recommendation is to follow the quick sizer tool, where there are three categories like easy, medium, heavy, based on the amount of data, based on the number of users. Classification like easy, medium, heavy is made in the increasing order. So overall, this SAP node will help us analyze and decide on what sizing suits the SAP HANA appliance implementation. So this is the PDF which I was talking about, and yeah, this zip file contains all the scripts explained above. Well, that was about explaining the first node where we decide on how to size the SAP HANA appliance. Moving on, let us now study about the quick sizer tool. By quick sizer, I mean it is the SMP quick sizer, service marketplace quick sizer. It is basically a web-based tool which is designed to make the sizing of SAP Business Suite solutions. So the result of using quick sizer is to calculate the number of CPUs, amount of memory and the disk size required. As explained, this is the URL where we have to navigate, and after navigating we will be allowed to choose two versions: Classic, HANA. Classic is for non-HANA databases, HANA version is for in-memory database, that is HANA. So we have to choose the HANA version here and furnish the required details, where we will have to provide the customer number, the product details, and the sizing can be done based on the amount of data or the number of users, and the end result will be of this format, where it will display the number of CPUs that has to be used, and amount of memory and amount of disk to be used in MB and GBs respectively, and also mention the computing unit performance called as SEU performance category here. What category class should be considered? For HANA, the suggestion is to choose AAA SEU performance. SEU is nothing but single computing unit performance. So with this result, we can then proceed ahead to size the hardware. Okay, number of CPUs, amount of main memory, and amount of disk to be used for installing a HANA appliance. And moving on, SAP has designed a concept called t-shirt sizing, where for different levels of implementation or for different scenarios, different t-shirt sizes will be used, ranging from XS to large. Different combinations of number of CPUs, amount of main memory, amount of disk size is decided upon and can be leveraged whenever a HANA implementation has to be done. So based on the scenario and based on the environment we are working, we have to design this t-shirt sizing. There's no standard sizing picture available. Based on our implementation environment, we have to design such t-shirt sizing for easier implementation going ahead. One sample example would be where this picture shows about small, medium, large implementation. So a basic formula what has to be used, the recommended one for sizing CPU and storage is as follows. CPU to memory ratio should be 1:16 GBs. Like for every one CPU, 16 GB of main memory should be there. That's the basic formula used. And coming to storage, storage is where the data and the log areas are stored. That should be 4 times the total memory required. So by total memory we mean the amount of data that is to be kept, amount of productive data of the solution to be kept. So it is 4 times. So of these 4 times, the division goes like this. For data area it is 3x and for log area it is 1x. How? Why data area needs 3x? Could be a question. Data area would not only contain the actual data, it would also contain a data export or some set of executables. So of this 3x, 1x is reserved for the actual productive data, the persistence data, and another 1x is reserved for probably taking some sort of exports of the database, and another 1x is for storing some executables which can be shared across multiple servers in case of a multi-node system. By multi-node we mean multiple hosts combined together to act as a multi-node system, a single system, but with multiple hosts for achieving better performance or for load balancing. There are multiple advantages of having a multi-node. We'll come to that later. So for having a set of executables which can be shared across multiple hosts, one edge size is reserved, and log size is always equal to the total main memory required, that is 1x again. So in the small picture you see that for small category we need 16 CPU cores and memory is 256 GB. Based on this formula, this sizing is calculated. And storage again, based on this formula, storage is calculated 4 times the main memory. Accordingly, for medium, we have a similar formula implemented where we see 32, 512 GB and 2 terabyte storage. A large, again 64 CPUs, 1 terabyte of main memory, and 1 into 4 times 4 terabytes of storage. So using this formula as a base, you can decide on the sizing requirement for your environment and prepare a t-shirt sizing recommendation which can be used at any point for any sort of HANA implementation. Now coming to step 3, which is about hardware check. By hardware check, again, it means checking the hardware before we perform the installation. So here we check the hardware configuration using a check tool, which acts as a framework that provides tests and reports to determine if the hardware which we use would meet the performance criteria required for SAP HANA to run in productive use or not. And also, this hardware configuration check can give us information about any problems that would be present in the hardware which can result in a failure of HANA implementation. So by knowing this result beforehand, we will be able to avoid any unwanted issues during HANA implementation. So to perform this check, there is a check tool, as I say, which comes as a part of a SAR file. No doubt, now this hardware check is implemented as an automatic check along with the HANA installer. The HANA installer like STB, INST, STB, LCM that we use for installing HANA database server already has this check in its algorithm. So before the installation is executed, such configuration check is performed. Only if the result of the check is positive, installation will be proceeded. Otherwise, the installation aborts, saying there is a failure of hardware configuration check. Before we run this configuration check tool, there are certain prerequisites recommended that must be present. So we must make sure we have the library NUMA1 version 2 installed on the server already. Second check is we should make sure open source network measurement tool IPOV is already installed. Third is that should make sure we have already exchanged SSH keys between different hosts to be used in the installation. And last one is that we have to make sure all servers have a resolvable FQDN. FQDN is fully qualified domain name. And we need to have a binary file SAP called SAP car, which is needed to extract the hardware check tool binary to a SAR file. Using SAP car -xvf option, we extract the SAR package, and the location where we download the package, the hardware check tool package, is given here. You should go to download center in service marketplace, choose support packages and patches, go to index H under installation and upgrades, choose the platform edition of HANA, and go for compile software component versions, and there you have an option to choose SAP HANA hardware config check. So under that you will find the SAR file. Or other option is that the software installation package for HANA platform edition what we download also can provide this hardware check tool SAR file. So once the HANA package is unpacked, we will get data units directory. Under that we will have SAP HANA HWCCG directory, under which we can find this SAR file as well. So once the SAR file is provided, we will have to extract it using this option as I say, and we will have this new directory created. HANA shared HWCCG is created. Make sure all necessary permissions are there for the files under this directory, and within this directory we will have a Python script called HANA hwcheck.py, which is responsible for running the check. So in this directory, using the option Python HANA hwcheck.py command, the configuration check will be executed and the result will be displayed. So based on the result, we can proceed, otherwise do the necessary corrections. As said earlier, this check is now automated to be a part of HANA installer itself. So there is no need to exclusively run this step unless it is very much necessary. Now let's move on to step 4. Step 4 talks about file system preparation. As you all know that for doing any installation, we should have the file system ready. File system where we store all the necessary installed files. Could be executables, it could be instance files, it could be data area, log area, backup files. So for all this, we should divide the volume that we have, the hard disk that we have, into multiple file system mounts so that we can segregate the data for easier access. So what are the necessary file system layers that we need? First one is HANA shared SID, where the instance will be stored. Next is USR SAP SID, again where the standard way of storing the instance. From traditional SAP system installation methodology, this is a standard mount where the instance gets stored. So this mount is also necessary for that. And next is HANA data SID, where the data area gets stored in the form of data volumes. There will be different data volumes for different services of the HANA, different components of the HANA, which will be stored under HANA data and the SID. Next is the log area, HANA log SID for storing the log area, where the appropriate component log volumes will be stored. From logs I mean the redo logs. Okay. And finally, a mount for storing all the backups. For safeguarding the data from persistence layer, we have to trigger regular backups which will go to this mount. So from this mount, then we can move it to a third server for keeping this data in a safe location. Could be on a tape using different techniques that we have, supported vendor techniques that we have. We will move this backup to another server called backup server. So that was about file system preparation. So we have to make sure we partition the hard disk to create all these file systems and make sure all these file systems have the necessary permissions so that we don't face any issues during the installation. So to do this, server management expert, like in simple terms, a Linux expert, operating system expert in the team can help us in getting this done. Next is about getting the installation package. Yes, now we have the hardware ready with proper sizing, file system, hardware check is done. Yes, now we can download the installation package for proceeding with the HANA database server installation. So again, we have to go to service marketplace. This is the URL to the service marketplace, that's software download center. From there, you have to choose installation and upgrades. Choose SAP HANA platform, that is SAP in-memory SAP HANA. Under that, you have to choose HANA Platform Edition and HANA Platform Edition 1.0. So there you will get the packages for particular release that you want. Could be support package stack 7, 8 or 9, where 9 being the latest available in the market. Download all the packages. There could be 3 packages or 2 packages for that particular support package stack. Download them, unpack them so that you will get all the subdirectories. Subdirectories would contain the necessary installers for only the database server, or installers like SDVLC and SDVLC going, and installers for studio, installers for client libraries, installers for additional apps on top of HANA like LC apps, EPM, Shine, AFL. So all the directories will be in this stack. You can directly use them, run the executable and install the required apps once the database server is installed. So firstly you have to install the database server, then only you can install all other apps on top of it. Okay, so now till here we have understood how a prerequisite check has to be done. Okay, once the prerequisite check has been done, we will proceed ahead with the installation. For installation, we will first have to log in with user root. Log into root shell. Just verify the file system. Again, to repeat the hardware check as a whole, and navigate to the software package downloaded directory where the software package is unpacked and where we have all the subdirectory, and from there we need to run the installation tool. So now let us study about installing the HANA database server installation, standalone HANA DB installation. Okay, so once the package is downloaded, we have to navigate to data units STB server, and this installation is on Linux operating system, Linux x86 64. So navigate to this directory and we have to start the installer from the start. And the installer, the basic installer that we will be using is STB INST, called as the HANA DB installer. So just issue /STB INST, and this is the kind of screen that you will get. It will first show you the database installation kit detection information, the release what you will be installing, and then it will query you for a set of inputs. First input will be the installation path. You have to choose the installation path where exactly the installation has to be done. So by default it is HANA shared, but you can customize it as per your requirement. It could be USR SAP also, as I said in my previous explanation. So after providing installation path, next is you have to provide the SID. You know, HANA DB gets installed as an instance. You know that each instance has an SID, a system identifier. So you need to provide the system identifier and then provide the instance number, the unique instance number. By default, it will take the next free instance number. So in any server, first free instance number will be 00. If 00 is not free, it will look for next free instance number and that will be prompted. 00 is not available. Otherwise, you can go with 00 or customize according to your name. You can provide any number of your choice. This will be the instance number of HANADB instance in this server. That next you will give the data volume location. You have to choose a location where data area has to be stored. And accordingly for log volumes, you have to choose a location where log area will be stored. And after all this information is furnished, you have to know that installation will create a standard admin user called system, which will have all the admin privileges on the HANA database. So this user gets created during installation and the password for which will have to be provided by us. So give us strong password with a combination of uppercase, lowercase, numerical and a special character, and 8 characters is the minimum length, and reconfirm this password, and then it will ask you for an option where you can enable restarting of the instance if the server gets rebooted. You can choose yes or no for that, and after that option is provided, yes, the installation starts. It will check the installation, prepares all the packages. These are the standard packages what it will install, like CPU staging, Python support, runtime, binaries, installers. So all this that configuration files, and then extracts the software and installs them. And then it creates the system, starts the HANA database, and there are some standard delivery units which will be provided with every support package stack. Those will be imported into the database. Finally, once the installation is done, the log file of the installation will be created in this location. The location directory is var tm /var/tm, under which you can find the installation log and you can go through it for knowing more details. Now let us check in the server. Let us do a hands-on to understand how the installation is executed. I have logged into the Linux server. Command UMI shows which user I am logged in with, that is root, and df-h will show me the file system preparation. So the hardware check is already run on the server and it is positive. And as I said, we need to prepare these file systems. USR SAP HAN will be the SID which I will be using. USR SAP SID, that is USR SAP HAN, will be the instance directory. HANA data HAN for data area, HANA log HAN for log area, HANA shared HAN again for the instance directory, and HANA backup HAN for storing the backup. So this file system is already prepared, and next step is we can navigate to the installation package which is unpacked and run the installation. This is the installation package directory. We have unpacked the installation package, and these are the packages that we get as a part of the support package stack. and this is for SPS 8, and these are the packages. As I explained, we have packages for installing the HANA DB server and HDB LCM, as I explained, is also available here, and HANA DB Studio client as well for different platforms where the client and studios are supported. To know that Studio is supported for Linux as well as Windows, and client is supported for multiple operating system platforms: Windows, Solaris, OS 400, NT Intel. For Excel as well, we have Linux, AIX, HPUX, and apart from these, as I say, we have hardware check package as well under this. The SAR file will be under this, and additionally, we have application packages, that is apps on top of HANA to be installed packages as well, like LC apps, EPM, INA Toolkit, Shine, AFL, River, File Load, and many others here as well. And we will have SWPM package also, which is an installer again for SAP installations, and HANA LM Lifecycle Manager, which will be explained later. Now let us proceed to install the HANA database server. I will navigate to HDB server Linux operating system. List the subdirectories and the files. Yes, these are the installers as I explained. HDB inst is an installer, and likewise we have other installers like HDB LCM, LCM GUI, HDB setup, and this is the upgrade tool, and this is the uninstallation tool. These four are the installation tools, and this is the uninstallation, and this is the upgrade tool. Now let me run the installer HDB inst. Apart from HDB INST, HDB LCM is another installer, but the advantage with HDB LCM is that it allows us to install multiple components. By multiple components, I mean it allows us to install database server, client, studio, and few other apps in one shot, whereas HDB INST installs only the database server. Let me come out of this. I shall explain you HDB LCM as well. See, as I told you, HDB LCM will install all these components, whereas HDB INST would install only the first component, that is the SAP HANA database server. So HDB LCM, apart from this, would install AFL, LC apps, client, studio, smart data access, and HANA LM Lifecycle Manager as well. This is more beneficial. Let me proceed with this. So I will select 2, where we are going to install new system. HTA is an existing system on the server which is already present, and it is currently stopped. Now let us proceed to install a new system. So I choose the option 2. I say enter. It takes a while to load. Okay, this is what I explained. See, here you can choose to install all components, or you can choose to install only the database server, or you can choose individual components also, like Studio, HLM, Client, AFL, LC App, Smart Data. So basically, in general practice, we first install the server, and based on the further requirements, we will install Client, AFL, LC App, Smart Data, HLM, if required at all. Otherwise, we will just keep the server. Now let us choose one, since I need only the HANA database server to be installed. Okay, I choose the default values. Now I keep SID, HAN, which is the system identifier. As I said, by default it will take free, the minimal free instance number. 00 is the starting instance number. Since 00 is already taken up by HTA, 01 is prompted for installation. So I say yes for it. Just enter to choose the default value. Now next step is to specify what type of a system this will be. That is the system usage. So here by production we mean it's a productive system which will be used in real productive world. So it will have real data. And next is test. For any sort of sandbox testing, any quality assurance testing, test system will be used. So basically the productive data will be copied to the test system and any sort of testing can be done on top of it. Next is development system, where new developments, new innovations can run. So there we choose development. Next is custom. So this will neither be a production, nor test, nor development. It could be a mix of all. It can be used for anything. Okay. Now let me choose 2 as it is a test installation. Okay. Next is about where we need to store the data area, the data volumes. So by default, it takes this location, as I say. So I choose enter and log volumes. By default, HANA log SI, that is HN. I choose yes to this option also. So next is about restricting the maximum memory allocation. Here we can specify a fixed amount of memory to be used for HANA database, or otherwise by default SAP HANA database will consume 90% of the RAM. So if for example 100 GB is the RAM allocated for the server, SAP HANA database by default will take 90 GB. So if our requirement is not to give 90 GB, we can custom set this value, say for 80 GB, or maybe we can set to a value above 90 GB as well. So in this I will keep the default value as 90%. So I choose enter, and next is it will ask for the certificate hostname. It will create a set of certificates for authentication, and hostname has to be assigned to this. So HANA OS is the virtual operating system name which is assigned to this IP. So we will choose that now. And yes, an admin user at the operating system is SID ADM. Here it is HAM ADM will be created during the installation, which will have admin privileges at the operating system level. So admin privilege for accessing all the files, altering all the files will be owned by this user called HAN ADM. In general, SID ADM. So we need to specify a password for this user as well. It should be a strong password with a combination of uppercase, lowercase, numericals, and special characters. Reconfirm the password. Okay. Now it has accepted the password. So this user will be created with the password that we have entered. Next is it will create a home directory for the instance. So HAN, which is the SID which is going to be installed, will have a home directory. The system will have a home directory. The standard one is USR SAP HAN home. I choose the default value. So next is about the shell, the login shell, SH, CSH, CSH shells. So I choose SH as the default shell, and user ID for the admin user 1002, and the time zone, the universal time zone. And next is the database admin user. As I explained earlier, A database admin user by name system will be created, which will have all the database privileges on the HANA database. So you can do any sort of configuration changes using this user, and can drive upgrades, can install apps. So varied amount of activities can be done using the system user. So this system user gets created during the installation, and for which we need to provide a strong password as well. Okay, once the password for the system user is provided, next, as I said, it will ask whether the instance has to be restarted whenever the server reboots. Could be some unplanned reboots due to some issues, due to some crash at the hardware side. Then the instance automatically gets stopped. So when the server is rebooted, that is restarted again, we can specify for automatic restart of the instance as well. So I choose yes for that as a safety measure. Then enter this value, and now it will give a summary of the execution. So here we can just verify our inputs of the installation path, the system ID, SID, instance number, system usage, test system, location for the data volumes, location for the log volumes, what we have specified. And the host name, what we are going to use, certificate host name, system administrator home directory, that is HAN ADM user home directory, the login shell of the user, user ID of the user group ID, that is always a part of SAP sys, and the time zone of the user, and an option whether to have an automatic restart if the server is rebooted, and the software components that will be installed. So here, since we chose only SAP HANA database server, it will show the version that will be installed, and also show whether other components are specified to be installed or not. So upon verifying all these details in the summary, we can choose to continue the installation. So say yes and then enter. So now it will proceed to install the SAP HANA database server. We'll install all the necessary components in this. And this installation would take quite some time, and also it depends upon the server speed, that is towards the network speed. And once the installation is completed, as said earlier, the log file will be available in the location /var/tmp. And make sure you see the message of installation as successful. So with this, once all the packages are installed, this is the kind of information that you will get, saying installation done, then see the log file for more details. Now let us move forward to learn about other installation tools as well. Next one is HTTP LCM, also termed as HTTP Lifecycle Management Installation Tool. So as I showed you the installation packages that we get, we have a directory called HTTP LCM there, which will give the HTTP LCM installation tool. And also under HANADB software, that is HANADB server software package, we will have HTTP LCM as shown earlier. So to navigate only to this particular package, you have to choose data units, HTTP LCM, and the operating system directory. There you can find the HTTP LCM installation tool. I have already explained about the differences between HTTP INST and HTTP LCM. So to run installation, what is the command that we use? So we have to run the installation using /HTTP/LCM, give a space, double hyphen, action is equal to install. for installation. So then the interactive installation starts. Or you can just mention /stblcm and then you can continue with the installation from there. Just issue stblcm with / option and then it will show you the same picture as shown below. It will allow you to choose what components are to be installed, whether only the database or do you want to install any other apps or the client or the studio or the lifecycle manager. Just proceed with the options as I explained earlier and it will complete the installation. So in the same way stbinst would also work, but stbinst would just install only the database. It will also ask you for the same set of inputs as you saw with stblcm. And next installation tool is HDB-LCM GUI. This is again a part of HDB Lifecycle Management installation toolkit, but with GUI option. So here again you have to navigate to the same HDB-LCM package under data units and you will see the installer file called HDB-LCM GUI. This offers the user interface. There is no much difference between HDB-LCM and HDB-LCM GUI apart from the GUI what you will be getting where you can just enter the inputs and monitor the installation. So you don't have to run it on the server as a command, but just issue the command and then rest everything happens on a graphical user interface. So as seen here, there are multiple options like interaction mode, which is the default, can be done using LCM, and batch mode is possible with HDB-LCM, but batch mode is not possible with HDB-LCM GUI. See, for installing the HANA database, now you got to know about the tools that we can use, but there are two modes as well. One is called the interactive, other the batch mode. Interactive is where you can interact while the installation is running, whereas batch mode is by providing a configuration file and the installer reads this configuration file and performs the installation. So we don't have to monitor the installation in that case. That means we don't have to interact with the installation. The installation runs on its own using the configuration file as an input file and does the installation based on the parameters and the values that we have specified inside the configuration file. So next option is about this automated installation, that is the batch mode of installation using HDB-LCM shown here and a config file. So basically, to summarize, interactive mode is possible with both HDB-LCM and HDB-LCM GUI, but batch mode is possible only with HDB-LCM. So this is the sample configuration file hana_install.cfg, and this is how it would look. You have to provide the SID, the instance number, and the user group ID in the same order as mentioned here. There are some more values what you can mention. You can mention all the values, like for example the user passwords and the installation path, the data volume, log volume path, everything can be furnished in this HANA install.cfg configuration file, and you have to run the installer by feeding this configuration file using the _config file is equal to the path of the configuration file. So run this command .htb-lcm with _config file is equal to HANA install.cfg file, and it will do the installation in an automated way in the batch mode. You don't have to intervene, monitor it, but it will do the installation, and then you can monitor or check the log file which is stored under var.tmp for any probable issues that could have arisen. So with installation, We will get the data and log volumes created. As I explained earlier, there are different data and log volumes created for different components, different processes of the HANA DB. For STB name server is STB 001. For Access Engine it is 2, Statistic Server 3, Index Server it is 4. Likewise, log volumes would have the same naming convention, but under the data and the log area respectively. So under the data area, we will have MNT 00001 as the parent directory for the data volume, and similarly for log volumes, we will have the same naming convention. So this is for one host. In case if we have multiple node system, that is multi-node system with multiple hosts, for first host we will have MNT 00001. For second host we will have MNT 00002. So accordingly, the volumes, that is HTB volumes for different processes according to the multi-node convention, would be present in the appropriate parent directory. Note that in a multi-node system, there would be only one statistic server and only one access engine in the entire system. Okay, that would probably be in the first host installed. So from second host, we will just have the name server and the index server data and log volumes respectively. Okay, apart from data and log volumes, we will have to verify the HANA DB profile. HANA DB, as we know, is created as an instance with an SID. So each instance in SAP terminology will have a profile, a system level profile. And the location of this profile is like this: USR SAP SID, sys profile. This is the naming convention of the profile: SID, HTTP, instance number, and the host. So navigate to this location, check for the permission of this file, and read the contents of this file, of the profile, to understand what are the parameters that it will have. Next is, there are some property files, also named as INI files. So there is something called as system local properties and system global properties, and the location for both is different. System local properties will define properties locally for the system. It's not, say for example, we have a multi-node system where there are multiple hosts. Local properties will specify host level parameters only to that particular host what are the values specified. Whereas global level properties will have global system global values, which is globally applicable for all the hosts, that is for the entire system. Whereas local properties is only for this particular host. That's why it's stored under the directory host. So there will be such property files under each instance of each host. Say for example, in the first host we will have such file host 1, and host 2 will again have these set of files. Whereas coming to global, this will be a shared directory across all the servers, all the hosts, and these files will exist as one for all the hosts, be it host 1, host 2, host 3. So it is globally applicable for the entire system, that is in simple words for all the hosts. So coming to local property files, we have daemon.ini, log, SAP profile.ini, tmp, trace, wdisk, work. So all for different usage. SAP profile.ini will have the properties of the instance, local instance. Log will have some logs. Log will show some logs created. Daemon will have information about the services that are installed, the processes that are installed. TMP will have temporary files. Traces will have traces. WDS will have some configuration files. Work will have the logs. Again, some working logs. Trace will have all sorts of traces in HANA DB. Coming to global properties, global.ini. Each INI here, global.ini, index server.ini, name server.ini, statistics server.ini will have a set of parameters which are grouped into sections. and are clubbed under each INI. That we will learn later. Okay. So once the installation is completed, we will have to navigate to these directories to read whether the data volumes are created, log volumes are created, hmm, profile is created, and whether we have the local properties files, global properties files. So we need to verify all this, and then we can proceed with the post installation steps. As I said, after the installation, we have to log into the server just to verify whether the instance, the executables, the data volumes, log volumes, profiles, configuration INI files are created or not, and also whether the HANA-DB is running or not. So, as I said, the data and the log volumes will be created. I've done a listing on the data area location. HANA data HAN is the data area location, and MNT is the data volume parent directory, under which we have 1, 2, 3, 4 for different processes, different components of the HANA-DB. And likewise, we have the log volumes also under HANA log HAN MNT parent directory. We have HTB 1, 2, 3, 4 for different servers or different processes, or in other terms, different components of HANA-DB. We have exactly the same number if you see for data and log volumes. As I say, it is created only for 4 processes of HANA-DB: index server, name server, access engine, and statistics server. And next is we have to verify the creation of HANA-DB instance under HANA shared HAN or USR SAP HAN. We have HTB01, which is the instance directory. 01 is the instance number. So under that, you see that we have HTB executable, which can be used to know the status or to check different information about HANA-DB. We use HTB executable, and we have certain environment variables grouped into different files like HTB admin.sh, HTB settings.sh, HTB settings.csh files, different files again. And we have a backup directory, standard backup directory. So to trigger a backup, now the backup files will be created in this backup directory. And exe for executables. HANA OS, this is the hostname directory under which we will have certain subdirectories. I will show you that. And again, these are some of the environment variables: HTB-env, HTB-env, .sh, csh for HTB ADM user, or HAN ADM in this case. And work is where the logs are stored. Now let me navigate under HANA OS. See, as I told you, these are the system local property files. I'll do a cat to display the contents of daemon.ini. See, as I told you, this will have information about the processes running. So here it is showing statistics server, access engine, SAP web test. And now let us do a cat on SAP profile, which will show the system information like whether Unicode or non-Unicode, and instance number, SID, what is the instance name, that is HTB01, what is the localhost name, HANA OS, and value of IPC shared memory 01, which is 600 by default. So again, if you navigate under another important directory, trace these are the traces generated for different processes. Again, name server, preprocessor, statistic server, access engine. You can see that different traces are generated, and HTTP daemon status will show the overall status of the system of all the processes of HANA DB. And we have some more log files for ICM, web dispatcher, startup, SAP start, compile server, index server again. So various traces and various logs will be available in this trace location, which you can refer in case of any troubleshooting. You have to navigate to this location to see what's wrong. You can read different logs files, different trace files to understand what is wrong and what has to be corrected. So that was one of the important directories. Now let me go to the profile directory. This is the standard profile directory, and two profiles by default will be generated with installation. That is default.pfl and other is the HANADB profile. The naming convention SID underscore STB instance number underscore host name. So let me do a catch on the default profile. So this will show the SID, the global host name, which is the host name, and the parameters is to be linked, shared, which are the default parameters, and config type is default. These will be the default values on the default parameters with installation. And any ad hoc configurations are to be made manually. Any custom configurations are to be made manually with different parameters by updating the default.pfl or the HANA profile. Similarly, let me display the HANA instance profile. So this is the HANA instance profile, where you can see different information about paths, auto start enabled or not, again system name, host, instance number, instance name, the directory for executable profile, and various other envs, environments which are such, and yeah, and various other configurations where it has to read from, and how the start of HANADB works, the HTTP start. Okay. So once all these are verified, now you can check the status of HANADB. So to check the status of HANADB from the OS level, you have to log in with SID ADM user, that is the OS admin user. In this system it is HANADM. So once I log in, I will be directed to instance directory, which will be the by default directory when you switch to SID ADM user. Now issue the command stb info to know the processes of HTTP which are running. So by default, we see that SAP start is the default process which will be running, and see that daemon is running here, and daemon will control all this processes: HTTP name server, preprocessor, compile server, index server, statistic server, access server. These are the different processes of HANADB, also considered as different components of HANADB. And web dispatcher is another component to serve the web request and also act as the load balancer when configured. So SAP start SRV is the default process which has to run for any SAP instance to run. Now again, STB version will give you information about what version we have installed and which weak stone is that and what type of compilation is there in this. So we have installed SPS 8 with this patch, and it is optimized compile type, and yes, this is the compile date when this revision was or weakstone was created. So another command to check the status is stbproc, which will give the same information as stbinfo. And another way of checking is SAP control. Using the SAP control executable, you can again check the status of any instance running, any SAP instance running on the server. So similarly for HANA instance, we'll use the convention SAP control -nr, give the instance number 01, the convention okay. This will show status of each process. So the status is known by the color code, whether it is red, yellow or green. Red means it is stopped, yellow is it is not completely running, and green is it is completely running. So as I said, STB daemon is the parent process which will control all other processes. You can also see the status of all other processes. So once you verify all these are green, then it means that HANADB instance is perfectly installed and is running fine, and there's no problem with this. So after verifying that, well, to be clear, verifying the status of the HANADB is a part of installation as well as post installation steps. Now let's study about what are the post installation steps that must be done after the installation is done. So firstly, as I said, verify the status of STB processes. So from OS level, you can issue STB info or STB proc with the help of HTB executable, or use the standard SAP control executable to check the status using this command with -nr instance number -function get process list. Then from this we can know the status of HANADB, that is the status of each process of HANADB, whether it is running fine or not, and from when it is running also can be verified. The start time will be displayed here and the appropriate PID, the process ID, will be displayed here. Now let us know about how to find the HANADB status other than from the operating system level. This slide speaks about HANA Studio, that is installing HANA Studio and using HANA Studio. So what is HANA Studio first of all? HANA Studio, as we studied earlier, is a tool for doing administration activities as well as development and modeling activities. There are a lot of options with HANA Studio. You can do export import, you can set up replication, monitor replication. There are various number of options available with HANA Studio. Now in this slide we will understand how to install HANA Studio. From the software package for the HANA support package stack that we have downloaded, we have to navigate to data units, HANADB Studio, and the particular operating system platform, so that you want to install it on Windows or Linux. Navigate to the particular directory, and in that we have to launch the htb setup.exe file to start the installation, and this will ask for the installation path. For example, in your Windows operating system drives, you have to give the default path, or you can custom the path to be of your choice, then run the installation. The installation runs for some time and it completes, then you have the HANADB Studio ready to be used. So once the installation is completed and the first time you launch the HANADB Studio, you will get this screen where you can choose the admin console or modular or development or life cycle management consoles, and also read some documentation. So with this picture you are good to go with the admin console. So this picture below shows the admin console. Once I click on this admin console here, I will be navigated here, and here in the systems view, I will have to add the system. Right click, choose add system, and you have to specify the system information, that is host name, instance number, description, and the language to be used, and the folder. The root folder will be selected by default. Choose next. Then it will ask the connection properties, whether you want to specify the operating system, SID-ADM user, or the database user, system, or any other database user that you have created. Of course, by default, only the system user will be created. Further on, we will have to create additional users. So, firstly, I will add the system user, give its properties. I can store the password for future use also by clicking on this. Then I click on finish. So after HANA-DB installation, you have to navigate to Start, Programs, SAP HANA, click on HANA Studio. This will take some time to load, and here we go. Since this is not the first time I'm using this tool, I am directed to admin console, which was my previous selection. So in the admin console, we know that in the systems view, we have to, you can create a new project, new folder, and then add it under that, or directly under the root you can add a system. Specify the host name or the IP address, give the instance number, give a description, and then choose next. I choose system user, system user credential, I say store username, and I say finish. If the username and the password is incorrect, then we will be prompted to give the correct details. Since I gave the incorrect password, I am now going to give the correct password. Since I don't want to log in with SID-ADM user, I want the database user to access the database in the studio for my admin activities. So I say no. Then I'm prompted to give the correct password. So once I furnish the correct password, the login to database worked, and here we have the system added in the systems view of the HANA Studio. On keeping the cursor on this, you can read the status with the host name and see whether all services are started or not. The yellow color here indicates that some services are not running, whereas green would have indicated all services are running fine. Now let us see what service is not running. I would go to landscape here. You have to adjust the HANA Studio view properly so that you can see all the status properly. So now you can see here we have to, first we will have to navigate to overview tab where you can see the general information of the HANA database, and also see the disk memory and the CPU consumption here, and also see some alerts if they are generated. Then go to landscape. Under the first tab services, you can see all the processes, whether they are running or not. Here all the processes of HANA are running fine, but SAP Start SRV seems to be not running properly. So this has to be checked at the operating system level, and might be a restart of the SAP Start SRV can solve the issue. Using the SAP control command, the executable command, we can restart the SAP Start SRV process. Then the color of this would turn green. So that was about checking the status in HANA-DB Studio once the HANA-DB Studio is installed and the system is added into it. Now let's move ahead to learn how a HANA client is installed on the application server. Say for example, an application solution with AS ABAP as the type, is using HANA as the database. Could be as a primary database or a secondary database like a data mart. Then it makes sense if this application has to connect to HANA database, a client has to be installed. HANADB client has to be installed. This client is a set of executables, and after installing the HANADB client, HTTP user store, which is the secure store for the connectivity users, must be created in the server. So to install the client, again we have to navigate to the software package of the stack which is downloaded, navigate to data units, and there you have a directory called HTTP client and the operating system. Here we have chosen Linux x86-64. So navigate to the directory, and there you have the installer by name HTTP inst. So use option HTTP inst along with -a and client. So that will again detect the installation kit, mention the version, and then proceeds to install. By default, this is the default location, your SAP HTTP client, but you can custom set this location based on your niche, and then it checks the installation, prepares all the packages like Python runtime, manifest files, DBC files, API files, some repository tools, ODBC, JDBC libraries, client interfaces. So all these packages will be prepared for installation, then the installation runs. So once the installation is done, we have the installation done message, and again the log is stored in var_tmp location. You can go to the directory here and see the HTTP inst client log. So as I told you earlier, HTTP client is available for different platforms. For AIX, HPUX, we have different Linux operating systems supported. For MS Excel also, you can connect Excel also to the database. You can install a client for that. And yeah, Intel OS 400, Solaris Spark, Solaris x86, Windows x86 as well. So for multiple operating system platforms, we have the client libraries available, so that solutions running on these multiple operating system platforms can be connected to HANADB server and leverage the HANA database. Now moving on to understand some more post installation steps apart from installing the studio, installing the client, knowing the status of the HANA database from the operating system level and also from the studio. Next is about adjusting the memory location. Memory is reserved to HANA database using the parameter global allocation limit. As I told you earlier, by default 90% of the server RAM, that is memory, will be allotted, will be taken up by the HANA database for its use. If we don't want to offer 90%, offer something less than 90% or maybe give more than 90% based on the requirement, we can custom set this using this parameter in the global.ini configuration file and the global properties location. So for that, there are two options to set. One is that from the studio, we have to go to configuration tab and filter for memory, search for global.ini under that global allocation limit, or directly issue this global allocation limit in the filter, then you will be shown that parameter. So before setting this, make sure you go to landscape services tab, see the consumption, memory consumption, how it is running, and make an analysis whether to decrease or increase accordingly, because increasing the memory allocation and then not offering that memory from the operating system would lead to out of memory situations. It's hazardous and may lead to crash of the HANA database. So make sure enough memory is available and you offer only that amount of memory which can be offered, which is in the bandwidth. So once you have analyzed as shown here, go to configuration tab. From there you can go to global.ini, search for this parameter and then mention the value accordingly. And again, another option for setting this value is from the operating system, where you have to go to global directory, that is your SAP ID says global STB custom config. Under this you will have global ini file, and you have to place this entry. So you can mention the value. 0 is like the default. What do you want to set? If you want to set some particular value, you can mention the value here. 8 megabytes. Well, let's navigate the configuration tab, and here is the global.ini file. There, I navigate to memory manager, and here is the value. So with installation by default, it has taken 0 as the value, which means 90% of the RAM will be reserved. So if I want to custom set this, I would mention the value here and save it. And then from there, I need to restart the HANA database to make this value effective. So once I set the value, this green color gets enabled under system. For any parameter here which are segregated into sections, we have system level value and host level value. So as shown here, I have made the system level value as 24,000 MB. So this turns into green color in the list view there. Whereas if I change it here, then this becomes a host level value. Whereas when this matters is in case of a multi-node system where there are multiple hosts, say for example host 1 and host 2, if I make the entry here, then this value is applicable for both the hosts. It is global to the system. Whereas if I make the value entry here, then it becomes to that particular host which I have chosen. In this drop down, I can choose which host I want, whether host 1 or host 2, and make the appropriate entry accordingly. So this turns into green color. But to make this value effective, I would have to restart the HANA database using this option. Right click on the system view and choose restart. Make sure you have enough downtime to do this enablement. And similarly, from the operating system, you can navigate to global location, which is this location. Okay, here you will have global dot. Since I have made the setting from the HANA DB Studio, this value is reflected here. Otherwise, this wouldn't have been there and this would be empty. I would have to manually make this enter. Now we have made the entry in Studio, that's why it has reflected here. So from here we are good to go with a restart. So now that we have understood how to set the memory configuration as a part of the post installation step. Now let's move ahead to know few more post installation steps which we have to do as soon as the installation is done. Firstly, we have to request for HANA license based on the memory limitation which is specified from the service marketplace. Go to keys option in the service marketplace. From there we can use the standard procedure to download the HANA license, and we have to navigate to properties tab, properties option in the HANA Studio. Right click on the system, go to properties, and we get the option license there, so we can install the license using this option. So once the license is requested, we get a notepad with the license information which has to be imported here using the install license key option. So store this notepad into any local location on your Windows server, then load it when the install license key browses for the file. Let's see in the studio how this would look. I've right clicked on the system's view, chosen properties. Well, this offers multiple configurations here. You can set the password, you can set additional properties here, and also see hosts which are used to connect IP address, the port numbers, and do the tracing. And you can set different properties here which we will learn later. Now let's go to license. So here we can see the hardware key and the SID, and what is the memory allocation that we have reserved to 24 GB as we did earlier in the previous step. And when was, what is the license type presently there, which is temporary. Well, temporary license is available for 3 months. So within this 3 months, we have to install a permanent license based on the duration of the system to be available as productive. If within 3 months we don't install the license, then the system locks out. Then we have a standard procedure to unlock the system. Then immediately we have to install the license. And the license start date is today, since we did the installation now. And so this is the 3 months validity. And we have the hardware key SID. This is the install license key option. Click on this. This is how it will ask you for the notepad file, which is the license file. So once this is done, you are good to proceed with the remaining steps. Remaining post installation steps would be, after installing the license, remaining post installation steps would be like using the HANA Lifecycle Manager to customize, update the SAP HANA system. You know this. Once the system is installed, it moves to lifecycle phase. The installation goes like this: planning, building, then the maintenance phase, which is called as the life cycle of the system. Then when it is not needed, it will be dismantled. So during the life cycle, we have to customize the system based on our need. We can update our HANA system to the latest HANA DB stack available. So this customization can be done using HANA Lifecycle Manager. In other words, it is called as HLM, which is a part of the Studio. This is the option which you have to choose after right clicking on the system in the systems view. This will offer a lot of options for us to customize the system. So make sure we go to Studio, right click on this, and after clicking this, it will ask for the HAN ADM, that is SAP ADM credential, and it will give us a picture for doing various customization. More details into this we will learn later on during the operations chapter. Now, yeah, after doing that, but make sure we have a latest backup before doing any customization, because as soon as the installation, a backup is unnecessary so that we can safeguard the data. Because during customization, if something goes wrong, if the system crashes due to some incorrect customization, then using this backup we can recover the system. So using the Studio or using the SQL commands, we can trigger latest backup to secure the business data, which can be later on moved to some backup server. And further on, using the configuration tab, we can do any sort of configurations, parameter level configurations, specifying different values for the parameters based on the requirement. Also at the operating system level, using the ini files, we can custom set the values for the parameters. And next on, create necessary HANA DB users or modeling users, development users based on the customer needs. Provide the appropriate roles, privileges. We can also create privileges, roles, custom set privileges and roles based on our needs, assign them to users. And further on, deploy additional apps. As I told you, we have AFL, LC apps, EPM, Shine apps packages available along with the stack. We can use any of them based on the requirement. We can deploy any of them using the installers available. These are nothing but, again, using the STB-INST installers within these packages. Run the installers and it will install the apps on top of the HANA database server. So these are some of the basic post installation steps that we do as soon as the installation is completed. So firstly, verify the status, make sure all the directories, files are present, and then install the license, do customizations, and make sure you trigger a backup before customization. Create users, do any configuration changes, install additional apps. So all these are a set of basic post installation steps. Now let us move on. So once the post installation steps are done, next step in the life cycle would be to monitor the system, do performance analysis, do performance tuning, so support the system during the life cycle. So then the productive use of the system keeps running. So when the productive use of the system is coming to an end, we plan to dismantle the system. That is, for example, if for example I have installed a system for a test purpose and I am done with the testing activities, quality assurance activities. And next step would be to free up the hardware by uninstalling the system. That is called as dismantling the system. To save cost, I would have to uninstall the system, hand over the hardware back. So how do we do this uninstallation? The software package that we have downloaded from the service marketplace for installation also offers the uninstallation executable, which is called by name STB uninst. So what we have to do, we have to navigate to the package data units, again STB server, issue the STB uninst executable. This will detect all the installed instances in the system. See here, for example, it has detected an SID called HTA, which is an HANA instance with instance number 00. So you can enter the value of this, enter the key value of this instance, then you are good to go with uninstallation. So from there it will warn you saying all the data volumes, log volumes, all the subdirectories of the SID will be removed with this uninstallation. Once you are confirmed that yes, I can uninstall the system, go ahead, click, press Y and click enter, and the uninstallation begins, where it will uninstall the entire database, removes all the database instance files, directories, and uninstalls all the packages. So once the uninstallation is done, it will issue a message saying uninstallation is done and log file is written inside this var tmp directory as std uninstall log. So this is how we uninstall a system. Then we are good to dismantle the hardware, that is return the hardware and save the cost. So basically from this explanation, from this session, we have understood how a HANA system is implemented. As I say, it has different phases: plan, build, and then install, and then support during the lifecycle phase. So planning would basically mean preparing the hardware, sizing the hardware, and decide on what solutions to be installed. And then build is where we install, and next is we do some post customizations, that is during post installation steps, and then the support. During support in the lifecycle phase, we monitor, do the performance tuning, and serve any service request, need anything to be newly installed on top of HANA. Then once the use of the system is completed, we finally proceed ahead to dismantle it, that is uninstall it. So with this explanation, we have come to the end of this session.